Hello, I'm Gale Tenen Spak. I'm an Associate Vice President at New Jersey Institute of Technology. NJIT specializes in STEM, and you can think about us like a polytechnic. The university is located in an urban setting in Newark, New Jersey. Newark was once the fourth largest manufacturing city in the United States of America. It isn't any longer, but the topic of my paper really does deal with manufacturing. This presentation focuses on the nexus between manufacturing in the United States and educational innovations. In particular, the focus, the perspective is always from that of workforce. What is manufacturing?
Was, glaub es kaum, alles was von Hand gemacht, das geht grad vorbei. Ich schau mich sing ein Lied, davon das nichts sich liebt. Komm mit mir, egal wohin, nimm meine Hand und lauf. Stell dir vor, wie im Traum, seh ich was, glaub es kaum. Alles, was für Hand gemacht, das geht grad vorbei. Sag mal, weißt du wie es jetzt wär ohne sie? Ich nehm dich mit auf mein Weg, sing mein Lied, das noch nie. Sag mal, weißt du wie es jetzt wär ohne sie?
Today, there are two ways of talking about manufacturing: legacy manufacturing and transformative or advanced manufacturing. But no matter what, something is being made. It's just how it's being made. And when we talk about advanced manufacturing, we are really talking about leveraging new technologies which require higher levels of skill than ever before. Manufacturing plays a critical role in the U.S. economy today. That's because it generates $1.8 trillion of the U.S. gross domestic product. This is 12.2% of the total of the U.S. gross domestic product. But most importantly for this paper, for every one job in manufacturing, there are 5 other jobs required. Let's talk a minute about this multiplier effect. While it's absolutely clear that the United States and the global economy need more engineers, more scientists, and more mathematicians, or 3 of the letters in the STEM acronym. The one letter that represents the most number of jobs is the technologists, the T. 75% of manufacturers in this country today say that they're going to go out of business if they can't find these men and women, because without them they cannot expand their businesses. This is the dilemma of this paper and what I'd like to talk about more. Why can't they be found? And this has to go back to the issue of the image of manufacturing today: dirty factory floors and menial work. Today in the United States, it is an aging workforce with no young people coming into it. They don't think there are careers in manufacturing. So if you ask 18 to 24-year-olds how many would consider a career in manufacturing, 52%. But 61 will say they want a professional career. This is a professional career now. Traditionally, skill gap replenishment happens in the United States, either in the high schools or the vocational schools, which issue diplomas, or at the 2-year community colleges in our country, which issue associate degrees and do training, and at the 4-year colleges in America, which do bachelor's and higher degrees in all STEM areas. But in this context, the situation that's happening is that the High schools and vocational schools cannot attract enough students into the programs that they have, so the supply is limited. And the four-year schools have not yet given the same regard or esteem to the T letter in the STEM acronym as they do to science, engineering, and mathematics. This is where innovations in education come into play. Two educational innovations stand out for their relevance to this problem. Massive open online courses, or better known as MOOCs, and Stackable Credentials credits. MOOCs have become very popular with educational innovators, and Stackable Credentials and credits are of particular relevance today to the manufacturing sector. Let's start with MOOCs. I'm actually going to refer to a definition in Wikipedia about MOOCs. MOOCs are aggregate classes from multiple organizations offered on a single computer platform. The courses are free for now and largely non-credit, but this is changing. The term connotes open access in that learners do not have to be registered at any particular college to enroll. They cost nothing and are scalable. The scalability is an amazing feature of MOOCs. Scalability in MOOCs actually means that one teacher is responsible for hundreds of thousands of students. One teacher, 100, 200,000 students. Because of the massiveness of the students per course, two popular forms of pedagogy are used to instruct these students. And they are either peer review, which is sort of like cloud sourcing, so reviews that are done in a Amazon.com kind of review way of other people's work, or automatic online feedback, which does make it possible to give a student some feedback, but largely it's based on true and false answers. A student would probably experience in a MOOC a video of an instructor and then have the opportunity to interact in this limited way with their professor and their other students. There are four major MOOC players right now, and they are Coursera, edX, Udacity, and Udemy. All four have different financial models backing them up. Three of the four are for-profit companies. One of them is a not-for-profit company. None of them are yet financially stable. Three of the four deal exclusively with what would be considered elite universities, largely in the US, but now expanding globally. Only one of them is really making it possible for experts of all sorts to be able to be the leader of a MOOC. Of special significance, completion rate is dismal. At best, 10% of the folks who take a MOOC are finishing it to the end. There are many pros and cons about MOOCs, but you cannot deny their price being free, their scalability, meaning, wow, so many people could get educated with good content from very fine faculty, and there is credibility because of the faculty who are teaching it. What if MOOCs were used to help educate for free, for no money, more technology adept production workers? And indeed, that's beginning to happen unintentionally already. For example, the very topics which manufacturers have said are needed in the workforce that they lack, the adept workforce, are already MOOCs. Calculus, pre-calculus, electric circuits, bioelectricity. This is all needed in manufacturing. And due to a separate MOOC development, these very courses are already capable of being accepted in over 2,000 American colleges for academic credit. This is where the second educational innovation comes into play: stackable credentials and credits. Stackable credentials refer to the fact that increasingly global industry sectors, including U.S. manufacturing, are looking to hire individuals with specific certifiable skills. And to be able to bring those folks that have these skills to higher and higher levels of skill so that they can be employed in higher levels of jobs. These industry sectors are not so much interested if the person has just a high school diploma or even a college degree. It's the skills that they have to do the job that's necessary. Some thoughtful researchers have really tried to develop a taxonomy of what makes something a stackable credit or credential. And there are 6 known and commonly accepted attributes. The first attribute of a stackable credential is that it's industry recognized. Industry experts versus educators have verified that this is exactly what needs to be known in order to get a job done. The second attribute is stackable, which means one credential builds on another, sort of like prerequisites in the college experience. One course builds on another. The third is portable. A credential cannot be just specifically and exclusively that one company says they need their workers to know, because companies differ. Proprietary information. It has to be portable from one company in that domain to another. So there are more generic in sense of what's really the core of what needs to be known. Number 4 attribute is quality controlled by an outside entity, not a single manufacturer, but rather a group of experts who have said this really is what needs to be known. And in the case of manufacturing, there are national associations who have done work on this area. So it's a group of nationally known manufacturers who may not even use the MOOCs or the stackable credits on their own, but they say this is what is really needed in our industry sector. Number 5 is this credential has labor market value. What does that mean? Okay, so here is a module, kernel of learning that definitely meets an industry need, but how many jobs are needed in that industry? And we really are looking in the stackable credentials movement to see that it is needed very commonly across the country. It will fill a workforce need. And finally, the attribute number 6 is that the stackable is part of a career system. That means there are clear education, training strategies, mechanisms, and supports for individual learners to move from the acquisition of core skills and credentials to higher levels of employment. And I want to put the focus on employment. Clearly, such a system could be and is today germane to advanced manufacturing. But the problem isn't solved yet, because today in the United States, the wages paid to those in this sector are not that great. So now let's move it to what does that mean? And how does one get higher wages? And it is a fact that cannot be denied that the more traditional education you have, the higher your chances for getting a better salary. So I would offer that a 7th attribute really is necessary to this system. And it is one that uses traditional higher education as a means to enable workers to earn family-sustaining salaries in manufacturing. It really becomes about the 7th attribute, the acceptance of the credentials by U.S. colleges for academic credit in their curricula leading to degrees. That is, today, the acquisition of an academic degree relates more to a person's self-interest than to the employer. An employer might be quite happy for an employee to finish at the 6th attribute. They know something that will get them into the workforce and be useful. But frankly, from an individual's point of view, it's that traditional education degree that makes the difference. About the use of stackables in manufacturing, the National Association of Manufacturers has an amazing system in place already, which does exactly 1 to 7 in the attributes. That is, they have developed through their affiliations 52 different standalone credentials which stack up, one on top of the other, in different aspects of manufacturing. They have also worked already in 26 states in America to have the community colleges in that system of those states accept these credentials for the relevant number and differing number of academic credits. About apples and oranges, or better known as MOOCs and stackable credits, are they the same? They're really not. They are both innovations in education. They both could go a long way to alleviating a real workforce gap in America in this one very vital sector, but they are different kinds of social, educational change agents. So when will U.S. manufacturing rebound? Let me play with the idea that I am a famous economic prognosticator. The famous economic prognosticator that I want to use is a very well-known and beloved figure, Yogi Berra of the New York Yankees. He happens to be a New Jersey resident living in a town very close, the next town over from NJIT. So I'm going to ask some questions to Yogi about, will the U.S. manufacturing economy ever rebound? Yogi, I wish I had an answer to that because I'm tired of answering that question. Yogi, the future ain't what it used to be. Yogi, you can observe a lot by just watching. Now, Gale, when will manufacturing in the U.S. rebound? I am not a famous forecaster. I am not a famous educator. But here's what I would say. It will rebound when we realize that at its heart, the so-called manufacturing skill gap in the United States is really a gap in education. And the two innovations that have been talked about now really could go a long way to ameliorating this gap.